On this video, we're going to work some more problems to prepare for the conics test. So here, the first one, we can recognize that this is going to be a parabola because we have one of the variables squared, but there is no x squared. So this is going to be in the form we want, x equals a y squared plus by plus c. So that is, we're going to get the x by itself. So I'm going to add the 3x to the other side, and I'll leave the y squared minus 6y plus 15 on this side. We can now do one of a couple things. I think I'll just divide through by the 3, so that'll make that 1/3 y squared and minus 2y plus 5. So we can find our vertex using, instead of x equals negative b over 2a, this will be y equals negative b over 2a, will give us the y coordinate of the vertex. So the negative b is going to be 2, and the 2 times a will be 2/3. So 2 divided by 2/3 is multiplied by 3/2 is going to give us a vertex that has y coordinate 3. We can plug that into our equation to get the x coordinate of the vertex. So that's going to be 1/3 times 3 squared minus 2 times 3 plus 5. So that's going to be 3 squared is 9. A third of that is going to be 3 minus 6 plus 5 is going to be 2. So our vertex is going to be at 2, 3. So let's see what that looks like. We've got 2, 3, and that's going to be our vertex. Now we can see that x is equal to a positive y squared, so this is going to open to the right, so I can safely name our vertex over on the left side and not get in the way of our graph. Now let's see, if we plug in, so an easy point to find is to plug in 0 for y, and when we do that, we can see that we'll get 5 for x. So I'm going to go 1, 2, 3, 4, 5. So 5, 0 is going to be right there. Then using the symmetry of the parabola, our symmetric point is going to be up here. It's going to be at 5, 6. And so our parabola is going to open to the right. Now we got to find the focus, and we know that a is equal to 1 over 4p, where p is our distance from the vertex to the focus. Our a is 1/3, so we have 1/3 is 1 over 4p. If we take the reciprocal of both sides, we'll get 4p equals 3, and so p is going to be 3/4. And our focus has to be on the inside, the interior of that parabola, so we're going to go 3/4 to the right of our vertex. That will make the focus be 2 and 3/4, 3. The directrix is going to be that same distance, 3/4, on the other side of the vertex from the focus. So since that's 3/4 to the left, that's going to make that be x equals 1 and 1/4 is that directrix. Okay, let's look at the next one here. So we can tell when we look at this that we have an x squared and a y squared both. Since they are different, since they are the same sign but different numbers, that's going to be an ellipse. So we're going to gather together the x terms, and I'll leave a space and then gather together the y terms, leave a space, and move the constant to the other side. We'll factor out the leading coefficient of both the x and the y terms, and so that will look something like that. We'll take half the middle term and square it and add that into the parentheses, which means we're going to have to add a 9 to the other side from the x term, and half the middle term squared is going to be 4 times another 4 is going to mean we're going to add a 16. So this becomes 9 times x plus 1 squared plus 4 times y minus 2 squared is equal to, that looks like 36. We want that to be equal to 1, so we'll divide through by 36, and our standard form of our ellipse is going to be x plus 1 squared over 4 plus y minus 2 squared over 9 is equal to 1. So our center is going to be at negative 1, 2. So we're going to go negative 1, 2 for our center. In the x direction, we're going to go 2 to the right and 2 to the left. And those will be our, since those are smaller numbers, those are going to be the endpoints of our minor axis. And so since our center was at negative 1, 2, that's going to be a negative 3, 2, and a 1, 2. And then in the y direction, we're going to go up and down 3. And so these will now be vertices. So that upper vertex will be at negative 1, comma 5, and the lower one will be at negative 1, negative 1. Try to draw the best ellipse that we can. We will solve for C to find out where we're going to place the foci. So remember, a squared in an ellipse is the bigger number, and b squared is the smaller number. So that's going to make our C be the square root of 5. Now, square root of 4 is 2, so this is going to be a little bit more than 2, and we want to be on the major axis. So we're going to go up and down. So we're going to go 1, 2, and a little bit. That is going to be one focus, and that will be at negative 1, comma 2 plus the square root of 5. And then we'll go 1, 2, and a little bit, and that focus is going to be at negative 1, 2 minus the square root of 5. And there's our ellipse. Now the next one, we can see we have an x squared and a y squared both, and we can see that the signs are different, so that will make this be a hyperbola. So as we have done with the ellipse, we're going to gather the x terms together and the y terms together and move the constant to the other side. We're going to factor out the leading coefficient, leaving a space, and that's going to make that be a y squared minus 2y. And so we will take half the middle term and square it. So we'll add 9 to both sides, and 1, which makes that a negative 16. So we have 9 times x plus 1 squared minus 16 times y minus 1 squared also. And let's see, that's going to be a negative, I believe, 144. So again, we want to make the right side be a positive 1. So since we have to divide by a negative, it's going to switch the order of these because I want to lead off with the positive term. Now 9 times 16 is 144, so this is going to make the y squared come first. That's going to be over 9. It's going to change the sign and make the x term be negative, and that's going to be a 16. So our center is going to be at -1, +1. So when we go to graph this, we're going to go -1, +1, and that's going to be our center. In the y direction, we're going to go up and down 3. 1, 2, 3. 1, 2, 3. So this is going to be one of our vertices. I'm going to put it off to the side here a little bit. That's -1, 4. And down here, that's going to be another vertex at -1, -2. We're going to go in the x direction 4 and -4, but we're not going to actually plot a point. We're going to use that to draw a rectangle. So we have 1, 2, 3, 4. I'm just going to put a little mark there, and 1, 2, 3, 4. Put a mark there. So this now is going to be our guideline for our asymptotes. So it's going to look something like that. So from our center going through diagonally through the corners of our rectangle, we're going to get our asymptotes. And so in point slope form, that's going to be y minus 1 is equal to, we have a rise of 3 and a run of 4, and then that'll be an x plus 1. And the other one will look the same, except it'll have a -3/4 for the slope. So our actual hyperbola is going to approach those asymptotes as we go way out to the right and left, and also contain our vertices. So now we have to find the foci, and in a hyperbola, it's the c² that's the biggest, that distance out to the focus. And so the a² is the 9, and the b² is the 16, so this works out really nice, that we're going to go 5 from the center. So from the center, we'll go 1, 2, 3, 4, 5. So that focus is going to be at -1, 6. And then we'll go from the center 1, 2, 3, 4, 5. So that's going to make that focus be at -1, -4. And there we have our hyperbola. So let's eliminate the parameter and graph. So to eliminate the parameter, we're going to try to solve for for t in one of those variables. And I think this one's going to be the easiest, because if we multiply by 2, that will become t equals 2y. We'll then plug that in for t in the other parametric equation. So that is going to become 4y² minus 4. Now that, hopefully, given what else we've done in this chapter, we can recognize that as a parabola that opens to the right. So when we put in 0 for the y, we're going to get x equals -4. So that's going to be -4, 0. If I plug in 1 for the y, we'll get 1² is 1 times 4 is 4, minus 4 is going to be 0. So a y value of 1 will be there. And if I put in -1, we'll get the same thing. So it looks like we're going to get this, but now we have to be a little bit careful. I think here, no, I think we're okay. So t can be anything there. So we're going to get, this is supposed to look like a parabola, but that looks pretty much like a corner point. That's supposed to be rounded in there by the vertex. So there is our graph. In the second one, got the green one here, we're going to subtract the 1 and then divide by 3 to solve for cosine of t. And similarly, we'll add 2 and then divide by the 3. Since we have one of those, I'm going to change that. One of those is supposed to have been a sine. So I'm going to change that one and make it a sine. So these are going to be sines. I don't know why it does that flashing. There we go. Okay, then we're going to use our sine squared plus cosine squared equals 1, our favorite trig identity. So that's going to be x minus 1 over 3 squared plus y plus 2 over 3 quantity squared equals 1. So we'll separate that and make it x minus 1 squared over 9 plus y plus 2 squared over 9 equals 1. If those 9s were different, it would be an ellipse, but since they're the same, we can multiply through by 9 and get our standard form of a circle. That was supposed to be a minus. So x minus 1 squared plus y plus 2 squared equals 9. That's going to be a circle with center at center at 1, negative 2, and radius of 3. So we can go 1, 2, 3, 1, 2, 3, 1, 2, 3. See, 1, 2, 3 there. I don't really want that one. And 1, 2, 3 is going to be there. So that point, the north point is going to be 1, 1. The east point is going to be 4, negative 2. The west point is going to be negative 2, negative 2. And the south point is going to be 1, 2, 3, 4, negative 5. And so we will get the best circle we can get through those points. Okay? All right, parametric equations. So there's lots of possibilities here for a line through those 2 points. So I'm just going to imagine that we're going to start at this point. So the x is going to be negative 1, and then plus, and then in order to go from negative 1 to 3, I'm going to say we're going to multiply by, that's a change of 4, so I'm going to call that 4t. So at time 0, the x value is negative 1, and at time 1, at t equals 1, our x value is going to be 3. And the y is going to start at 1, and then we're going to see, the y is going to start at 4. And from the 4 to the 1, we're going down by 3, so I'm going to say minus 3t. So there is one parameterization of a line through those 2 points. And there's others too. That's not the only one that would work. Okay, can we find an equation of a parabola that has vertex 2, 3, so there's our vertex, and focus 1, 3, so there's going to be our focus. So we know that this parabola is going to have to wrap around the focus. So we know it's going to be an x equals a times y minus k squared plus h parabola. We know that the h and the k, so we've got the h and k come from the vertex, so that's going to be y minus 3 squared plus 2. To find the a, we know that that is going to be 1 over 4p. P is the distance from the vertex to the focus, and that distance looks like it's 1. Because it's opening to the left, that means our a is going to be a negative. So our a is going to be 1 over 4p, and we know it's got to be negative. So our equation is going to be x equals negative 1/4 times y minus 3 squared plus 2. Here we go. Let's try the next one. Now we want an equation of an ellipse. And we've got vertices that are negative 4, 3, and 6, 3. So 1, 2, 3, negative 4, 1, 2, 3. There's going to be one vertex. And 1, 2, 3, 4, 5, 6, 3 is going to be the other. So this is giving us 3 pieces of information. We can tell the center is going to be halfway in between. From negative 4 to 6 is 10. If I count half of that, 5 over from the negative 4, that's going to give us a center that has x-coordinate 1, and its y-coordinate is going to be 3. We know that A is going to be that distance from the center to the vertex. That's going to be 5, and the a squared goes with the bigger variable, so we're going to get x squared over a squared plus y squared over b squared. So far we've got x minus 1 squared over the a squared, which is 25, plus y minus 3 squared over b squared, and we need to know what the b is. And that's where our minor axis is going to come in. The minor axis is always length 2b, so that means the b is going to be 4, which makes our b squared 16, and makes this our equation of that ellipse. Okay, let's try a hyperbola. This time we've got foci that are at negative 2, 1, 2, 3, 4. It's going to be one focus, and 1, 2, 3, 4, 5, 6, 4. So these are going to be our foci. And let's see, so the foci lie on what's called the transverse axis. So our center is going to be halfway in between. And so from negative 2 to 6 is 8. If I count 4 from negative 2, we'll get an x-coordinate of 2 and a y-coordinate of 4. That distance from the center to the focus is the letter C, and that looks like it's going to be, how much? So we said that was a negative 2, 4. I don't think I did that right, did I? So negative 2, 4, 2, 6, 4, that looks right. Distance between those is 8, half of that is 4, counted over 4, so that's going to make that C, yeah, so the C is going to actually be 4. Sorry about that. And let's see, what else do we know? We know that the foci lie on the major or transverse axis, so it's going to have to be a hyperbola that opens right and left. And so that means it's going to be an x squared over a squared minus y squared over b squared hyperbola. We also know that the slope of that asymptote is going to be a rise of b and a run of a. So that means b over a is equal to r 3/4. So let's see, how's that going to help us? We know that to find the foci in an hyperbola is c squared equals a squared plus b squared. So I'm going to cross multiply here and get 4b is equal to 3a. So I think I'll just say a is going to be 4/3 b. Could have solved it the other way. So c is 4, so c squared is 16. And so we are going to get the a, I'm going to replace by 4/3 b squared plus another b squared is going to be 16/9 b squared plus 1b squared is 9/9 b squared. So that's going to be 25/9 b squared is equal to 16. So I'm going to multiply by the reciprocal, and so that's going to get 9 times 16 is 144 over 25 is b squared. I don't think I need b, I just need b squared. So our equation is going to look like x minus the x coordinate of the center squared over the a squared. I got to find the a squared. So if b squared is, whoops, I don't know what I did there. I don't know what I did there. See if I can bring it back to size. Sorry about that. So if our b squared is 144, if our b squared is 144 over 25, and our a squared is going to be, did I have a squared anywhere? Yes, here we have the a. Here we have the a right here. So let's go ahead and solve for b. If we square root that, it'll be a little bit nicer to work with, 12/5. So our a is going to be 4/3 times 12/5. Yuck. So that's going to cancel and make that be 16/5, which means a squared is going to be a miserable 256 over 25. So our equation is going to be x minus 2 squared over a squared, which is 256 over 25, minus the y minus 4 squared all over b squared, which is 144 over 25 equals 1, or we could write that as 25 times x minus 2 squared over 256 minus the 25 times y minus 4 squared all over 144 equals 1. So I guess I didn't really use this part here. So I'll erase that. I think that's all we got for this one. Okay, very good.